Okay, before we start doing some examples, I just want to recap all the derivative functions or rules for taking derivatives that we have. We know the derivative of a constant is 0. We know that if we take the derivative of a constant times a function, the constant just factors out. We know that the differential distributes over addition and subtraction. We've got a product rule for differentiation that duv is v du plus v u dv. Got a quotient rule. Differential of u over v is v du minus u dv over v squared, or if you like, low d high minus high d low over low squared. We've got our power rule that the derivative or the differential of u to the n, the exponent comes out, becomes our coefficient, and the power reduces by 1. We have all the trig functions that we derived in class. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is tangent secant. Derivative of cosecant is negative cotangent cosecant. And then, as was derived in the previous videos, that the differential of a to the u is natural log of a to the u du. And the differential of log base a of u is 1 over ln of au du. Common mistake that I see with students is that they mix their power rule and their exponent rule. Remember where your constants are. If your constant is in the exponent, or if your constant is a power, then you're going to use the power rule. If your constant is the base, then you're going to use the exponential rule. And notice there's two very different answers. And so if you use the power rule on an exponential function, you will get it wrong. Or if you use the exponential rule, don't usually see that, but if you use the exponential rule to do powers, you'll get it wrong as well. So those are our basic rules in a nutshell. And so let's go ahead and look at some examples. Let's compute the derivative of cosine squared. So what is the derivative of cosine squared with respect to x? And as I will always demonstrate, I'm going to use my differentials to compute this. This is just really good habit, especially in the upcoming sections with chain rule and implicit differentiation. So I highly encourage you follow my pattern. So the differential of cosine squared of x. Let me rewrite this so it's a little bit clearer. This is the differential of cosine of x squared. Right? That's what we mean. When I put the 2 here, or I put a 7, I put any number here, I'm saying take the cosine function and raise it to that power. So first off, we see that we've got a power rule. So this is equal to 2 times the base, cosine of x, raised to the exponent minus 1. Well, that's 2 minus 1, but I'll write it here. 2 minus 1 times the differential of cosine of x. And that's equal to 2 times cosine of x times, and the differential of cosine is minus sine of x dx. Let me writing this a little bit more, so you recognize that's a negative. So this is negative 2 cosine of x times sine of x dx. So the derivative of cosine squared, the derivative of cosine squared with respect to x, well, you take the differential, you divide by dx, that dx will cancel, so what you get is negative 2 cosine of x times sine of x. And that's our answer. For another problem, let's take the derivative. Let's compute what the derivative of, say, x e to the x with respect to x. So following my pattern, take the differential of x e to the x. And you should recognize that this is a product, right? I've got x times e to the x. There's multiplication going on. So I've got to use my product rule. This is equal to x d e to the x plus e to the x dx. And the differential of e to the x, going up, technically it should be, so my base is e, right? My base here is e, so the differential of e to the x, so the differential of e so the differential of e to the x based on our rule is natural log of e to the x, but the natural log of e is 1, and so this is simply e to the x. Just wanted to make sure that we see in the exponential rule, e to the x should be our favorite derivative to take care of because it's simply itself. So this is equal to x e to the x plus, or dx, plus e to the x dx. So what is dx e to the x? Well, take this whole expression here and divide it by d to the x. And I get that this answer is simply x e to the x plus e to the x. Let's look at another one. What is the derivative of e to the x times natural log of x? So what is the derivative of e to the x times the natural log of x with respect to x? Well, computer differentials. So the differential of e to the x ln of x. What rule do we have to apply first? Well, it's going to be our product rule because this is a product of two functions. So the product rule says it's the, so it's going to be equal to the ln of x times the differential of e to the x plus e to the x times the differential of ln of x. And we've already, in the last part, we know that the differential of e to the x is e to the x. So this is equal to ln of x e to the x. And the differential of ln of x is 1 so e to the x times 1 over x dx. And we passed all the way through. And so dividing everything by d to the x, divide this thing by d to the x, and notice there's d to the x's everywhere. Cancel, cancel, cancel. I get that the differential of e to the x ln of x with respect to x is simply equal to natural log of x e to the x plus e to the x over x. That is what the differential of e to the x times ln of x is equal to.